Hi everyone, this is a video tutorial of me doing the test review. We decided to move the test to a later date, so it will not be on Friday. We're going to move it to next week on Monday or Tuesday. I will let y'all know tomorrow what day we're actually going to have it on. But this video is going to go through the answers and solutions to everything on the review. So if you get through the first couple problems and you don't want to watch the rest of the video, you just want to skip to another part where I do another problem, feel free to do that. You don't have to sit here and watch the whole video in its entirety, because that would probably take you a really long time, and I'm guessing most of you maybe don't need all of that extra practice. You could be good with doing like 1 or 2 problems from each section. But if you do need the extra practice, you can follow along as I go, okay? So the first thing that you're going to be tested over is being able to solve multi-step equations. So let's take a look at number 1. Zoom in. Okay, so first thing you want to do here is distribute. So I'm going to distribute the -3 and the 4 inside of those parentheses. So now you've got -12x minus 9 plus 24x plus 4 equals 43. And then you're going to combine your like terms. So you've got a -12x here and a 24x here that you can combine. That's going to turn into positive 12x. And you've got -9 and positive 4. Add those together, it's going to get you -5, and then bring down your 43. And I'm just going to keep solving, moving over terms. Okay, don't make the mistake here at the step where I divided both sides by 12. I saw a lot of you in class trying to subtract 12 from both sides. Remember that this is 12 times x, so to undo that operation of multiplication, you want to do division. Number 2, I'm going to distribute again. Oh my gosh. There we go. Combine your like terms. So I can combine these together, and I can combine these together. Okay, remember if you have plus a negative number, you can just turn that into a minus sign. So I'm just going to erase the plus sign that's there. Okay, now I can combine these two. I want to get all my x's on one side, so I'm going to add 15x to both sides so that I can get everything with an x on the other side. -15 divided by 3 is going to get you -5. All right, for number 3, distribute. Combine your like terms. So I've got this and this. I want to get all my numbers on one side, so I'm going to add 8 to both sides. -8 plus 8 is 0. So do not just stop at this point and say, it equals negative 61 or equals 0, whatever. We need to figure out y. We're going to divide both sides by whatever's in front of n. 0 divided by negative 61 is just going to give you 0. Okay? Number 4, distribute. And divide by 30 on both sides. Negative 30 divided by 30 gives you negative 1. Okay, on 5, that negative sign that you see out front is just like if you had a negative 1. So if you want to pretend it's a negative 1, that's fine. It's just going to cause the sign inside of the parentheses to change. Okay, let's combine like terms. So I've got this, this, and combine this, this, and on this side, these two. So the red ones, we're going to get 19x. The blue ones, we get 34. Okay. Now you can move whatever you want. It doesn't matter what you move first. I'm going to add 2 to both sides. Then I want to get all my x's on one side, so I'm going to subtract 19x from both sides. And then divide both sides by negative 18. And you're going to get negative 2. Okay, last one. I'm going to distribute that negative 4. So an easy mistake I can see y'all making is in the front of the parentheses, that 3 minus 4, do not combine those and make that negative 1 and then distribute. You have to distribute the negative 4 inside the parentheses first before you can do anything else. Okay, we can combine 3 and 12. And then move whatever you want. I'm going to add 4y to both sides. Subtract 8 to get all the numbers on another side. Divide both sides by negative 2. And there you go. Page 2 is asking, is it a function? Is it not a function? So if you're given a graph and it's asking you if it's a function or not a function, we're going to use the vertical line test. So when I draw vertical lines through this graph here, it's going to go through that graph at more than one point on one vertical line. So this one, maybe I'll draw it in green. Those green points are touching the graph on the same vertical line more than once. So this one is not a function because it fails the vertical line test. Same thing on this one. You have points where on a single vertical line, it's going to go through the graph more than once. So this one's not a function. This one, it's only going to go through the graph one time, so this is a function. And on the circle, I go through 2 times per vertical line. So that one is not a function. Okay, so if you're given a graph, just do vertical line test. Now we've got these tables and they want to know if it represents a function. So you're looking to make sure that there are no repeating x values. So if you see an x value that's written twice, it's not a function. The first table, you've got 5 and 5, so we can eliminate W. I have a repeating X value. On X, you've got 2 and 2 that repeat, so it's not that one. On Y, nothing repeats. You've got -2, 0, 2, and 1. Those are all different numbers, so Y does represent a function. On Z, 0 and 0 are repeating, so it's not Z. Okay. The next one, it says, which of the following relations describes a function? Again, you're looking to be sure that none of the X values are repeating. So on A, I already see I have zeros repeating. On B, I have the number 2 that repeats. On C, I have 2. So process of elimination, our answer choice has to be D. But notice that your X values are all different, -2, -3, 2, and 3. Doesn't matter if one's negative, one's positive. They're still different numbers, so that one is a function. All right, with mapping, you're looking to be sure that you have only one arrow per input. So the column that says input, every number on there should only have one arrow that comes out of it. So for W, we've got 13 has one arrow, 0 has one arrow, 8 has one arrow, and 10 has one arrow. All of the other ones, like for X, 6 has 2 arrows coming out of it, 4 has 2 arrows, and 10 has 2 arrows. So your answer choice has to be W. Okay. Number 11 says add another ordered pair to this relation that would make it not a function anymore. Okay. So just pick a point where you would have a repeating X value. So for example, let's take the point 5, 4, that very first point that's there. If I add another point to this relation that has an X value of 5, it is no longer a function because your X values are now repeating. So I'm just going to put 5, 10, and since my X value of 5 here and here is repeating, it is no longer a function. Third page is all about domain and range. So for part A, whenever you see a set of numbers, like you're given a set of points, that means you're going to use set notation. So that's going to be the squiggly bracket, X such that X equals, and then you're just going to list all of the X values of your points in order from the smallest X value to the largest. If a number repeats, like here, notice that 3 and 3 are repeating. You're only going to include it in your domain once. And you're going to close it off. The range, same thing, but I'm going to use Y values this time. Okay, is it a function? Well, we already know that we have a repeating X value of 3, so no, it's not a function. And is it one-to-one? Well, it can't be one-to-one if it's not a function, so no. Part B, it wants us to sketch a graph of the relation and list a domain and range. So I'm just going to plot these points. So I've got 1, -2, 1, 2, 3, 0, -5, 4, and -5, -4. Okay, so for our domain, I'm looking at the X values. And again, this is a set of numbers. It's a scatter plot. I'm going to use set notation. And I've got -5, 3, -5, 1, and 3. Okay, for the range, I'm going to look at this column. And again, make sure you order them from the smallest value to the largest value. Brackets are so gross. Oh well. Okay. Is it a function? Well, you have 2 errors coming out of 1 and 2 errors coming out of -5, so no, it's not a function. And if it's not a function, it can't be one-to-one. For part C, you're given a scatter plot. So this is going to use set notation again. I don't have connected dots. And for the domain, you're just going to list out all of the x values. So if it helps, maybe make yourself a table and list out all of the points that you've got. So we've got -2, -5, -2, 3, 1, -1, 2, 3, and 6, 2. So I'm just going to list out all those x values. If it repeats, I'm only going to write it once, so I'm only going to write -2 one time. Range, I'm looking at y values. And again, if it repeats, you're only going to write it one time, so the number 3 repeats, but I'm just going to include it once. Is it a function? Well, on your x column, you've got 2 of the same x values, and they're repeating. So is it a function? No. Is it one-to-one? No. Part D, same kind of thing. I'm going to draw myself a table and list out the coordinates. Okay, so my domain, I'm going to write my x values. Range, I'm going to write the y values. One is repeating, so I'm only going to write it one time. Forgot to put 0 in there. Sorry. Okay, is it a function? When I look at the x, I do not see any of those numbers that are repeating. So yes, this is a function. Is it one-to-one? Well, for one-to-one, you're looking for repeating y values, and I've got 2 number 1s there, so no, it is not one-to-one because of those repeating y values. All right, letter E, this is a set of connected points. So when it's connected points, you're not going to use set notation. You can either use interval notation or inequality. So automatically A and B you can get rid of because they're in set notation, okay? And this is asking for the range. So I'm looking at the y values. So draw yourself some boundary lines. This is the bottom of the graph, and then this is the top of the graph, or the minimum and the maximum there. Okay, so the minimum y value is down 1, 2, 3, 4, 5. So I know that -5 has to be in the front. And you've got an open circle, which is going to go with one of those 2 signs, okay? Your maximum of the graph is a closed circle, so it's going to go with one of these 2 signs, and it is at 7, okay? So it cannot be C because we're not even looking at -7 or +5. We're looking at -5 and +7, so your answer is D. Page 4 is just a little bit more tricky, domain and range. You have to be able to identify what kind of notation to use. So on letter F here, since you do have connected points, we're going to use interval notation, or you can use inequality notation, but I prefer interval notation. For your domain, you're going from left to right. So if you want to draw yourself like a little boundary line, you're going to have one right there, and then this one is going to continue going on and out forever. So your domain, the leftmost point that you're looking at is at -1, 2, 3, 4, 5. And since it's a closed circle, I'm going to put a bracket. So I'm going to go from -5 to infinity. And for the range, you're looking from the bottom of the graph to the top. So the bottommost value on your graph, since there's an arrow there, is going to go negative infinity. And the maximum value you reach is up here. That's at 1, 2, 3, 4. And it's a closed dot again, so I'm going to put a bracket. So is it a function or not a function? If I drew vertical lines through this, I would only go through the graph once at each line. So yes, it is a function. Is it continuous or discrete? Continuous means that you have connected points, and discrete means that you've got like a scatter plot or a table. So since these are connected points, it is continuous. For part G, now you're given just a scatter plot. So I'm going to make a table of values. Okay, and then I'm going to, in the domain, use set notation because it is a set of numbers. There, it's a scatter plot. So I'm going to use squiggly brackets and just list off my x values in order from smallest to largest. And I'm not going to repeat any numbers that repeat on the table. Okay, is it a function? On your table, you're looking for repeating x's, and I do have that, so no, this is not a function. Is it continuous or discrete? Since it's a scatter plot and not connected points, that's going to be discrete. This part has been the most challenging for most of you, so really pay attention here, try to get in the details. I'll try to explain it as best as I can. So for number 13, we're giving you two functions and asking you to verify if they're inverses. So you're not solving anything here. You're doing the composition in both directions, and then you're simplifying. But you're not going to be solving. So you cannot add, subtract, multiply, divide anything into the equation that doesn't already exist there. Okay, so if it wants f of g of n, that's telling you to look at f and replace the n with the entire g of n. So instead of putting an n there, I'm going to put 4n plus 16. And then all divided by 4. So this red part that you see here, this used to just be the letter n, but I replaced it. So now when I simplify, this and this are going to go. And you've got 4n divided by 4. Then the 4's are going to go, and you're just going to be left with n. So you're looking for it to simplify to just one letter. If you get it down to one letter, you have to check it in both directions. Let's say I had simplified this and I got like n plus 4. Those would not be inverses because my composition is not just equal to n. So since I did get one letter, I have to check in the other direction as well. So now I'm going to look at G and replace the n that's there with the entire f of n. And then simplify, so the 4's are going to go, the 16's are going to go, and you're going to be left with n. So since both of the compositions in both directions are equal to n, these two functions, f and g, are inverses of each other. Okay, for number 14, this is asking you to find the inverse. So this wants you to do the interchange x and y, solve for y, simplify. Okay, so first thing I have to put a y in my equation. Remember that g of x and y are the same thing. Then I'm going to interchange x and y and solve for y. Okay. I have 1 over y currently, so if I flip both sides of the equation, right now this has a denominator of a 1. If I flip both sides of the equation, I'm going to just get y. So I'm going to flip this side, and I'm going to flip this side, and we're going to get y over 1 is equal to 1 over x plus 2, which is just y equals 1 over x plus 2. So that's your inverse, but remember we want to write it in the notation that it was given to us. So remember to write g inverse of x equals this. Okay. For this one, same thing. Change g of x to y. Interchange x and y. Solve for y. Okay, and then simplify. Make sure you rewrite it as g inverse of x equals this. All right. Domain and range down here. So your domain, you're just going to pick off all the x values and list those out in set notation. And the range, you're going to pick off the y values and list those in set notation. Okay, the inverse, all you're going to do is rewrite those points with the x and the y values switched. Okay, the domain of the inverse is the range of the original function, and the range of the inverse is the domain of the original function because you've swapped x and y values. Okay. All right, we are on the last page. This is being able to find an inverse and then graph it. So first thing I would do is go ahead and find the inverse, and then after that I would graph both functions and your line of reflection. So interchange x and y, solve for y simplified, just like we did in the last page. When you get to this point, to get rid of the 1/5 in front of the y, you're going to multiply both sides by 5 to get the fraction to go away. So these are going to cancel. And if you distribute that 5, you're going to get 5x plus 5 equals y. And this is f inverse of x. Okay. So when I graph it, I'm going to use slope-intercept. When I'm graphing f of x, -1 is my y-intercept, and -1/5 is my slope. So I'm going to go down 1 and put a point on the y-axis, and then I'm going to go down 1 and run 1, 2, 3, 4, 5. I'm going to go up 1, 1, 1, 2, 3, 4, 5. Okay. And try. Then we connect those points. Okay, there's one line. And then I'm going to graph the inverse. So 5 is my y-intercept, and 5 is my slope. Since you can't go up 5 and over 1 here, I'm going to go down 5 and over 1. It's going to give the same graph. So now when I draw that line of reflection, it's going to kind of cut through the middle of my graph, and it looks the same on both sides of that line. So we know we have inverses. Okay? Ooh, sorry. Make sure you got that. Then I'm going to move it. Okay, for the next one, you're going to have to do some distribution. And then combine your like terms. Okay, now I can interchange my x and y. Okay. It did not give me any kind of function notation here. It just gave me the y, so I'm allowed to leave my answer like that. So when I'm graphing my original function, I'll circle that in red. My y-intercept is 5. And then I'm going to rise 3 and run 1, but since I can't represent that, I'm just going to go down 3 and over 1. Okay, I'll do this one in blue. I'm going to rewrite this so that it looks like something you've seen before. This is the same thing as 1/3 x minus 5/3. Okay, so my y-intercept is a little bit bigger than 1, so like 1.6-ish. Let me right here. And then you're going to rise 1 and run 3. Just get a couple points. Okay, if I draw the line of reflection through that one, I'm right here, and it's splitting my graph in two, so I know that I've got inverses. All right, this is our last problem, word problem. It's looking at the domain and range, maximum, minimum, and then the independent and dependent variables. So it gives us the equation. It tells us that he's getting paid $7 an hour for work and that he's working between 15 and 35 hours. So your independent variable here is going to be time, and that's the amount of hours that he's working. Your dependent variable is going to be the amount of money that he's earning in dollars. So the amount of money that he's earning is depending on the amount of hours that he works. Okay, so if you were to graph this, remember that your dependent goes on the x-axis. Sorry, dependent goes on the y-axis and your independent goes on the x-axis. So when I'm looking at domain, I'm looking at my independent variable. And when I'm looking at range, I'm looking at my dependent variable. So domain is looking at your time in hours. It tells us that he's working between 15 and 35 hours. So we're going to go 15, 35, and I'm putting brackets around those because I'm actually going to touch those points or reach that amount of hours. The range is looking at y values. So I know that I'm going to do 7 times the amount of hours that I work to get my total amount of money that I'm going to earn. So the minimum amount is going to be 7 times 15, and the maximum would be 7 times 35. So we're going to get 105 as the minimum, and 245 as a maximum. So for the range, we're going to go 105 to 245, and brackets again because I'm actually going to reach those amounts. Okay. It asks what does each value in the ordered pair mean. So remember that 20 is representing time and 140 represents money. So this is saying for every 20 hours or at 20 hours of work, Joe has earned $140 of pay. Okay? If you stuck with me through the whole thing, so proud of you. Great job. If you need any help or you have any questions, come see me in tutoring and we can get that worked out. Have a great night.